Congratulations on reaching the last lesson of our linear regression analysis section. Our focus here will be dummy variables. Apart from the offensive side of the word, there is another meaning, an imitation or a copy that stands as a substitute. In regression analysis, a dummy is a variable that is used to include categorical data into a regression model. So far, we used only numerical data, like the SAT score and the GPA, or the random 1, 2, 3 variable from the adjusted R-squared lesson. Now we will explore how to include variables such as gender, season, and brand into a regression we are working with. For instance, let's take our GPA prediction example that we all know so very well. Generally, another good suitable regressor for GPA is attendance. Here is a data set that includes a variable that measures if a student attended more than 75% of their university lectures. This is categorical data, so we cannot simply put it in the regression. Our approach for this lesson will be to go through the process of using a dummy and explain it later on. Okay, here we go. I'll load the file 1.03 dummies.csv into the variable raw data. As you can see, it contains a third column, attendance, which reflects if a student attended more than 75% with two possibilities, yes and no. What we would usually do in such cases is to map the yes and no values with ones and zeros. In this way, if the student attended more than 75% of the lessons, the dummy will be equal to 1. Otherwise, it will be a 0. So, we will have transformed our yes and no question into zeros and ones. That's what the dummy name stands for. We are imitating the categories with numbers. In Pandas, that's done quite intuitively. I'll create a new variable data equal to raw data. Then, I will overwrite the series attendance in the data frame. So, data, square brackets, attendance equals data, square brackets, attendance, dot, map. Then we must specify the entries to be mapped in their new values. Let yes be mapped to 1, while no to 0. That's the proper syntax to do that. After executing, we see that we have successfully created a dummy variable. The categorical data in the series was replaced or mapped to numerical. Great work! Let's take a look at the descriptive statistics of the variables. Notice that the mean of attended more than 75% is 0.46. The fact that the mean is less than 0.5 gives us the information that there are more zeros than ones. Since the two outcomes are 0 and 1, this implies that 46% of the students have attended more than 75% of the lessons. In any case, now we can create a regression that explains GPA taking into consideration both SAT scores and attendance. I'll load GPA and Y as usual and SAT and attendance in the variable x1. Once again, we must use the stats model method for adding a constant. Then we can fit the regression and get the summary as before. The result is the following. Our overall model is significant, the SAT score is significant, and the dummy is significant. The adjusted R-squared of this model is 0.555, which is a great improvement from what we got without attendance. The original model without the dummy variable was GPA equals 0.275 plus 0.0017 times the SAT score of a student. The model, including the dummy variable, is GPA equals 0.6439 plus 0.0014 times the SAT score of a student plus 0.226 times the dummy. Now, we said that the dummy is 0 or 1, so actually we can represent this equation with two others. If the student did not attend, the dummy will be 0, so 0.2226 times of 0 is 0. The model becomes GPA equals 0.6439 plus 0.0014 times SAT. If the student attended, the dummy will be 1, so the model becomes GPA equals 0.6439 plus 0.0014 times SAT plus 0.2226. Let's add the intercept and the dummy together. We get GPA equals 0.8665 plus 0.0014 times SAT. I will plot the data. There will be two equations, which I will call y hat underscore no and y hat underscore yes. They will represent the two equations we just talked about. Certainly, we can parameterize these equations, but there is no need for such a simple example. So, what we observe are two equations that have the same slope but have a different intercept. The students who attended are spread around the upper line. On average, their GPA is 0.2226 higher than the GPA of students who did not attend. We can even think about these as two separate regressions. Let me color the points, which refer to students who attended classes, so the red line, and students who did not attend, the green line. You can clearly see the difference now, right? Finally, I will put the original regression line on the graph. It is steeper and goes somewhat between the two lines of the dummies. Okay. To use this model for prediction purposes, we need two pieces of information: an SAT score and whether a person attended more than 75% of their lectures. Let's wrap up here. In the next lesson, we will explore how to make predictions using the regression model we just created. Thanks for watching.